This is a very important university question because this single problem gives solution to these many questions. If they ask z transform of cos n theta, sin n theta, k power n cos n theta, this is just an extension of this. Similarly, k power n sin n theta or e power minus a n cos n theta or e power minus a n sin n theta. For all these things, this is the procedure to solve, because it's like if I say k power n cos n theta, it's a particular case when k becomes e power minus a. So for all such questions, this is the solution. So we know that the formula for cos n theta is e power I n theta plus e power minus I n theta divided by 2. So we have to find z transform of cos n theta as well as sin n theta. So we know the formula for cos n theta. Now we are applying z transform on both sides. So z transform of cos n theta is 1 by 2 into z transform of e power I n theta plus z transform of e power minus I n theta. So this is nothing but z transform of e power I theta the whole power n. I n theta, I can write it as e power I theta whole power n. Similarly, the second one is e power minus I theta the whole power n. Now what is the formula for z transform of k power n? It is z by z minus k, right? So we are going to apply the same. So z transform of k power n is z by z minus k. So in the place of k, in the first one I have e power I theta, in the second one I have e power minus I theta. Formula is the same, but k is different in these two cases. So z by z minus e power I theta plus z by z minus e power minus I theta. Right hand side we have applied z transform. Now we have to simplify by doing cross multiplication. Z e power minus I theta on both sides. In the denominator we get z minus e power I theta into z minus e power minus I theta. And now by multiplying these terms we get z into z minus e power minus I theta into z into z minus e power minus I theta in the numerator, and the denominator z into z will become z square, z into e power minus I theta with a negative sign, it's coming here, again minus e power I theta into z, this term here there is a negative sign here in front of this, and last one minus into minus plus e power I theta into e power minus I theta. So what we will do, we will add the power I theta plus minus I theta, it will become e power 0 in the power, that is 1. Okay, and this z we have taken outside. So what we have left, z minus e power minus I theta plus z minus e power I theta in the numerator. This z and z will become 2z, and we have taken negative sign common from these two. So e power I theta minus e power I theta. Okay, so if I take negative sign common from this, this will become positive, and the second term also become positive. So I made it plus here. Okay, so if I take common, e power minus I theta plus e power I theta. Okay, so e power I theta plus e power minus I theta by 2 is nothing but cos theta, right? Cos theta formula is e power I theta plus e power minus I theta by 2. Since 2 is missing, we are multiplying by 2 in the numerator as well as denominator. So 1 2 will become cos theta, by 2 will become cos theta, and numerator 2 is still there here. So 2z minus 2 cos theta divided by z square minus, again same formula, 2z cos theta plus 1. So we have just replaced e power I theta plus e power minus I theta by 2 cos theta. So now we have got the terms, and by taking 2 common in the numerator, and this 2 and that 2 will get cancelled. So z minus cos theta will be there in the numerator, the denominator z square minus 2z cos theta plus 1. So this is z transform of cos n theta. So we got the answer for the first question, find z transform of cos n theta. Similarly, we have to find z transform of sin n theta. What is the formula for sin n theta? 1 by 2i e power I n theta minus e power minus I n theta. okay, and applying z transform on both sides. So 1 by 2i z transform of e power I n theta, that we can write it as e power I theta the whole power n minus z transform of e power minus I theta the whole power n. Same as that the previous question, we are going to apply z transform of k power n. What is the formula for z transform of k power n? Z by z minus k. The place of k, first one I have e power I theta, and in the second one I have e power minus I theta. So we have just applied the formula 1 by 2i z by z minus e power I theta minus z by z minus e power minus I theta, and we are cross multiplying these two. So z minus e power minus I theta will come here minus, there are two terms, the first term will become negative and this term will become positive because of this. So minus z plus e power I theta divided by, again in the denominator we have z into z, z square, z into e power minus I theta, because of this negative sign I have negative over here. Again this negative sign comes here, e power I theta into z, e power I theta plus minus I theta. So e power 0, that is 1. And in the numerator z and z will get cancelled. I have e power I theta minus e power minus I theta, and in the denominator z square minus z I have taken common from these two terms. So e power I theta plus e power minus I theta, and then the last term e power 0, that is 1. So this is nothing but 2 cos theta formula, because cos theta is e power I theta plus e power minus I theta by 2. 2 is missing, so I have written 2 cos theta. Same way the sin theta formula is e power I theta minus e power minus I theta divided by 2. So 2 sin theta we have in the numerator, and this 2 in the numerator and this 2 outside will get cancelled, okay. And this is not only 2, actually this is 2i, because sin theta we know the formula. I'll write it again. Sin theta is equal to e power I theta minus e power minus I theta by 2i. This 2i is not there, right? So 2i into sin theta we have written here. So these values will get cancelled. So we are getting z trans sin n theta, that is z sin theta by z square minus 2z cos theta plus 1. So we got z transform of cos n theta, we got z transform of sin n theta also. Now what we have to find? Z transform of k power n cos n theta, okay. So wherever z transform of cos n theta is there, replace z by k, then we will get this answer. What is that rule? Damping, okay. So in case in the exam if they ask this directly and you are going to use this formula whatever we have derived, so we have to derive only z transform of cos n theta. Say in the example, say in exam if they ask z transform of k power n cos n theta, so no need to find this sin n theta. First z transform of cos n theta you find it, and then apply the damping rule and derive it. That's it. What is asked, that you can solve the same. So if they ask z transform of k power n cos n theta, we are going to apply the damping rule. So if I know z transform of cos theta, I'll replace z by k in that formula. So this is what we have got, z into z minus cos theta by z square minus 2 cos theta plus 1. So wherever z is there, I am going to replace it by z by k. So we have written this and just change to z by k here. So if I take LCM here, z minus k cos theta by k, okay. So here outside 1k is there, and same way when I am taking LCM here, z square, denominator k square we have minus 2kz cos theta plus k square, the whole thing divided by k square, just LCM, okay. And you can take z by k common and you can cancel it also. That is again your simplification techniques, you can do whichever way you want, and by simplifying it we get z transform of k power n cos n theta is z by z square minus 2kz cos theta plus k square, and in the numerator z minus k into cos theta. So this is the formula, okay. So z into z minus k cos theta by z square minus 2kz cos theta plus k square, and if you observe there is no sign term here. So this is z transform of k power n cos n theta. Similarly, if they ask us to find z transform of k power n sin n theta, what we are going to do? Same. We got z transform of sin n theta already. Just replace z by k in that. Okay. Again I repeat, if they ask z transform of only this in the exam for 7 marks, you have to solve z transform of sin n theta alone and then derive this formula. This is what we have got. Then wherever z is there, replace z by k. That's it. By using this formula, you have to write it by using damping rule. If I know z transform of un, then z transform of k power n un is u bar of z by k. So wherever z is there, replace z by k. So z by k sin theta, z by k the whole square minus 2 into z by k cos theta plus 1. So that's why I have written z goes to z by k. So taking z by k common, and you can cancel it. Now LCM is very simple. Z by k, if you take common in the denominator, one more z by k is there. Here minus 2 cos theta will be left plus k by z. Okay. Because if you take z by k common, if you take z by k common here, this is what will happen. 1 is equal to z by k by z by k. This z by k has gone out. So 1 by z by k will become k by z. So sin theta by z square minus 2kz cos theta plus k square by kz. So this kz will come to the numerator. So kz sin theta by z square minus 2kz cos theta plus k square. This is z transform of k power n sin n theta. So in the question, if they ask z transform of e power minus an sin n theta, just replace k by e power minus a. That's it. I'll show that also. Yeah. So if they ask z transform of e power minus an cos theta, we have derived z transform of k power n cos theta, right? Just replace k by e power minus a. So this is the formula for k power, this is what we have derived for k power n cos n theta. Just replace k by e power minus a, we get this. Same way, if they ask z transform of e power minus a n sin n theta, replace wherever k is there, replace it by e power minus a. This is what we have derived in the previous page. So wherever k is there, I am going to replace e power minus a. So here e power minus a z sin theta by z square minus 2 into e power minus a z cos theta plus e power minus a the whole square. That's it. So this one problem gives the solution for z transform of cos n theta, z transform of k power n cos n theta, z transform of e power minus a n cos n theta. Okay. Same way, z transform of sin n theta, z transform of k power n sin n theta, z transform of e power minus a n sin n theta. So definitely one question will be there for VTU. Thank you.